This is day one on the gas laws unit and is a basic overall introduction to some of the concepts that we're going to be talking about. The goals for this section is that you are able to explain the factors that can affect gas pressure, that you can relate some real-world experiences to how they might relate to the gas pressure, temperature, and volume, and also that you are able to predict the behavior of a gas when one of those variables changes. Before we get too big into gases, we need to talk about something called the kinetic molecular theory. The kinetic molecular theory describes the behavior of an ideal gas. And we're going to talk more later about what the term ideal gas means, but just know that kinetic molecular theory just describes the way that gas acts. There are three major assumptions in the kinetic molecular theory. Overall, there's 5 points, but three major assumptions. The first one is that the particles of a gas will move in a straight line until they collide with other particles or the walls of the container. Those collisions between particles and with the wall of the container are perfectly elastic, which means that no kinetic energy is lost when those collisions are made. The second one is that the motion of the particles is constant and random. So they're moving around and they're moving around at random. Third major assumption is that there are no attractive or repulsive forces amongst those particles. So there's no attraction between gas particles. They are not going to form intermolecular forces when they get close together. They're simply just going to bounce off each other in those elastic collisions. A couple other parts of this. One being that the average kinetic energy of gas particles will depend on temperature, not the identity of the particles. So the kinetic energy itself is completely related to the temperature. The second part is that the gas particles themselves are tiny and very far apart relative to their size. So we say that their volume is negligible compared to the volume of the container. There are four variables that we use to describe a gas. The first one is pressure. Pressure can be found in units of kilopascals, millimeters of mercury, or ATM, and ATM is going to be the most common one. The second one is volume, and that can be in liters or milliliters. The third is temperature, and we always give temperature in Kelvin when we're working with gas laws. And the final one is the amount, and the amount we're going to use moles for. In terms of factors that affect gas pressure, one of them relates to volume. So when adding or removing gas, the amount of gas in a given volume, when that's increased, the pressure will increase. So for example, if we look at these two containers here and we double the amount of gas, we're going to double the pressure. Now pressure is caused by the collisions of the particles with the walls of the container. So the more particles you have, the more collisions you're going to have, which means the greater the pressure. The relationship between volume and pressure is a direct relationship. So if you double the amount of particles, you're going to double the pressure. As far as real-world examples go, looking at whitewater rafting, and the text underneath that figure there says real world. So if you've ever been whitewater rafting before, you know that the raft itself is incredibly important. And the strength and flexibility of that raft play a big role whether or not you're going to make it through or you're going to get booted out. So you got to think about what the raft needs to do. So the raft needs to be able to withstand the pressure of air in the raft itself, but it also needs to be able to respond to the forces that the raft comes across in terms of the rapid. If you have too much pressure in the raft, then you're going to have let me take a step back. If the volume of the raft is too big, then you have too much pressure inside, and the second it hits the rapids, that raft could burst. But if you have not enough volume in the raft, then the pressure is really low, and it's possible that the raft would sink. Another factor that affects gas pressure is changing volume. So if you decrease the volume of a gas, you're going to increase pressure. So for example, if we look at decreasing the volume by half, you can see now there's a smaller area for those gas particles to exist. So if we decrease the volume by half, we're going to double the pressure. And you can think about it, when we are decreasing the volume, we're increasing the amount of collisions the particles are going to have with the walls of a container, because now there's just not as much space. And the more collisions you have, the greater pressure you have. This relationship is indirect, so when one goes up, the other is going to go down. A real world example of that is opening soda cans and bottles. So typically when you open, especially like a 2-liter bottle of soda, you tend to do it relatively slowly to let the gas escape slowly. Otherwise, you're going to have it bubble and fizz up all over the place. And so in terms of chemistry, what happens is that when you open the cap, the gas itself is now able to increase its volume. So it's been compressed in a small space, and once you open the cap, now the gas can increase its volume in order to decrease the pressure in the can. This is why if you shake that carbonated beverage, you can have an even bigger explosion, because now you've increased the pressure within the can, and the second you open it, now you have a lot more pressure that needs to be released. Another factor that can affect gas pressure is temperature. And so as I mentioned before, the temperature of a gas and the kinetic energy of its particles are directly related. So as you increase the temperature, you're going to increase the kinetic energy. So if we look here, we have two samples, one at 298 Kelvin and one at 596 Kelvin. If I double the temperature, I'm going to double the pressure, and the reason why is because the more kinetic energy those particles have from the increased temperature, the more often they're going to strike the walls of the container, so the greater the pressure is going to be. This relationship is a direct relationship, so as you increase one, the other increases as well. The example that I have for that is aerosol cans. So aerosol cans contain a gas in a sealed container, and those aerosol cans can generate a lot of pressure when they're heated. That's why it says do not store above 120 degrees. Even empty aerosol cans, or cans that seem empty, like a hairspray can, they tend to still have some gas in them, and they will explode if you put them in a fire. Similarly, it's also not good to store those cans in really, really cold temperatures. If those cans were to freeze, the substance will expand, which could cause the can to burst as well. So that was just a really quick introduction to gases. If you have any questions, please don't hesitate to shoot them my way. Otherwise, this will correspond to worksheet number 1 in the gas laws unit.